All right, hi guys. So for class today, we're going to be doing this forces lab, our first lab here on forces. Okay, and what we're going to do on this lab is we're going to take one of these. This is a little car here. See that? It's a particle accelerator. Okay, is what we're going to call that. Right? It's got a little. I kind of like load this up, press the button, and it will shoot these let's shoot these different spheres out. Right, so that's there. Right, I'll shoot that sphere in one speed, in a certain speed, and certain should shoot them straight, but it's going to shoot them in a certain direction. Okay, so we're going to be doing this. I'm going to be going down the hall. Down, but I'm going to find some carpet outside where I can do this lab, so these things don't like go crazy far. So we have some more friction on the carpet, right? To where we can fill, to where we can get these to kind of stop, so I can measure them easier. Okay. Now, what we're gonna do here is I'm gonna just before we start, I'm gonna just weigh these so that we get a mass. Okay. Let's see. You guys can get you to read that. Yeah, you can read that balance there. So I'm gonna start with the brass one. Okay, and the brass one needs, let's just round that up. Let's just call that 65 for the brass. Okay. And then this one's glass, so I can tell that's lighter. Okay, we call that 21. Let's see, aluminum. Let's call that 24. Okay, and lead, let's call that lead 86. Okay, so we're gonna be testing those four out, and then maybe later on we're gonna use this steel ball. So we're gonna make some predictions with this steel ball. So you don't need to record this one right now, but the steel one would be 67 grams. And we're gonna come back to that. We're gonna come back to the steel one later. But those are the four masses that. Okay. So those are the masses plus the steel one that we'll come back to. So like I said, I'm gonna go take this stuff out into the hall. I'm gonna go find some carpet, probably down by one of the doors, one of those like rugs. Wipe your feet down by the entrance, and we'll shoot these out. We'll see how far they go. We'll see how long it takes. Okay. All right. So guys, I made my way. You can see I'm down here. Everybody on aquarium, and we'll see if anybody comes by as we're down here. But so I'm gonna go ahead and shoot these. I'm gonna go ahead and shoot these glass or the glass, the steel, glass, the brass, the aluminum, lead, and then the steel, and we'll save that one for later. Let's see. If you guys can see here, I'm gonna start. I'm gonna shoot them right along with this like edge of the wall right here. So I have a nice. Put the accelerator right by the edge of that wall, so I have a nice place to measure. And I got a couple meter sticks. We might have to move those. But that always covers me 2 meters, and then I'll go and move them further should I need to. I got my phone here. I'll try and keep tabs. Okay. So let's see. We got brass. Okay, we got the brass ball first. Okay. So I got that set up right. That's set up in the accelerator. This might be a little hard for you guys. It might be hard for you guys to see. Let's do what we can from here, right? I'm gonna get my timer ready. I'm gonna press those at the same time, and here we go. Let me redo that one because I didn't get the time. So Okay, perfect. Let's see that one. You can record the time is 1.8 seconds. Okay, so 1.8 seconds. Let's see, we're right over here on the blow. You guys can really read that. Let's say 67 seconds. So really in meters. Okay, so 67 centimeters is 0.67 meters. Okay, so 0.67 meters for the brass. Okay, 0.67. Okay, now let's see. Let's get the next one's glass on your list. Let's see. Now you're looking at what happens with the different weights, the masses. So the glass weighs a lot less than the brass does. Let's see what happens there. You can maybe get a prediction, and maybe we'll see. Let's go with that. Oh, a lot farther. And it took 3.0 seconds. And so it took 3.0 seconds. And let's track that. Let's track that. That is past the edge of my so I need to grab that first one, kind of line it up with this second one here. Right, and that, yeah, that's over here. So let me line that up, and that is 240. So yeah, 2 meters plus 40 centimeters, which is 2.4 meters. Okay, 2.4. So that one went a lot further, right? That, the glass went a lot further. So what do we got next? Aluminum. Let's see, that's the later one of the two. They kind of look the same. So we got aluminum. Yeah, this one's pretty light. Let's see what happens. And that one went for 3.6 seconds for the time. Yeah, 3.6 seconds. And you guys can see it way down there. Right past our 2 meter mark again. So it was, like I said, it was 3.6 seconds for the time. And this is going 2.5 meters. Okay, 2.5 meters that aluminum traveled. Just in general here about the uh-oh. There we go. Well, looks like I broke my rubber band here. Looks like I broke my rubber band here at the end. So what we're gonna do is we're gonna just say that for the lead, we're gonna just say it went. We're gonna say it went 0.4 meters. Let's say 0.3. Let's say it went 0.3 meters. 0.3. Okay, so we're gonna say the lead went 0.3 meters. Because yeah, this old little car, sure the plastic didn't snap, but the little plastic piece snapped off. So anyway, call that 0.3 meters because that would have been the least. And yeah, we'll go with that from there. And then you guys need to divide the distance by the seconds to get the speed. And then you can cross out the speed and the time for the lead one. Okay, you can cross out those. So you guys have that. And then the next thing you're gonna do is make your graph on the next page. Then you got a few questions to answer off that graph. Okay. And then let's see, we'll come back later. I'll give you the value for the CO1 in a little bit. Okay.